Today's lesson involves constructing scatter plots. So the first example that we have in our notes is to construct a scatter plot between height in inches and weight in pounds. So they already told you that the height is x and the weight is y. So before we make our scatter plot, we're going to label our x and y axis. And before we plot our points, we need to figure out what to count by. Now notice that we have these little breaks. They look kind of like sideways Z's. That's so that you can start at any number and do like a huge leap to that number and then count by whatever number that you want. So to figure that out, you should look at your smallest and your largest x value first. So it looks like the smallest is going to be 60. And the largest in our list would be 72. So we want to go from 60 to 72 and figure out how we can space those numbers to get those all listed in the X. And using this break in our data, if we actually start at 60, we should be able to count by ones to get up to 72 and still fit all that information there. So here's my X. I didn't label all the numbers, but I did count each block as 1 starting at 60. I just couldn't fit them all in there with my big handwriting. Now for the Y's, if we look at our smallest Y value, looks like our smallest Y value would be 102, and our largest looks like 165. So we need to go from 102 at least to 165, and it looks like if I start at, let's just say 100 from the break, and I count each block by 5s, I should be able to fit it perfectly. And again, because it's hard to write that small for me on here, I only showed every 2 blocks as counting by 10s, which implies that every block counts by 5s. And now I can just go ahead and plot all my points, but once you are plotting your points, don't make a line connecting them, just plot them normally. So here's my scatter plot with all my dots. Feel free to pause the video if you need to catch up to make all your dots. Obviously mine aren't going to be perfect, but that's okay. And then the first question we're answering about the scatter plot says to describe the correlation. Remember, there are 3 types of correlations. There are a positive, a negative, and no correlation. Now this is clearly a positive because as the X increases, so as height increases, the Y increases, which is the weight. So describe the correlation. We are going to write positive. And then question 2 says to describe the relationship trend between the 2 sets of data. So to describe it, you're going to say as height increases, weight increases. Then question 3 says, does causation exist between the 2 sets of data? Causation means, does one thing cause another to happen? So this can go kind of either way, but as you focus on the X first, can height cause weight to change? And yes, your height can cause your weight to change. So as you continue to get taller, your weight is going to change as a result. Now, if the X and the Y were switched, and we were asked, does weight cause your height to change? Then we would say no, okay? It's not like if you gain more weight, you're going to increase your height, or vice versa. So that wouldn't work. But on to question 4, is this data univariate or bivariate? Well, since it's a scatter plot, it has to be bivariate. All scatter plots are bivariate because it's comparing 2 different types of data. In this scenario, height versus weight. Now for question 5, to draw the line of best fit, try to grab a straight edge or a ruler or anything that you can make a straight line with, and you're going to draw that straight line through the points 66, 130, and 70, 155. So here are the 2 points that I'm trying to make a straight line with. Obviously mine is not going to be very good because it's on the iPad, but hopefully yours turns out better. And here's my line of best fit. And for number 6, we are going to use the same points that we drew our line of best fit through to find the slope. So if you remember the slope formula, it's the change in y's divided by the change in x's. So if we focus on first our y's, we're going to take 155 and subtract 130. And then for the x's, we're going to take 70 and subtract 66 so that we end up with 25 over 4, which will simplify to 6.25. So here is our slope of the line of best fit that we drew. Now to find the equation. Now, the equation, there's two options. In the past, we've used y equals mx plus b, where you would substitute your y value, your x value, and your slope, and then solve for the y-intercept. There is also the formula that I'd like to review now that we've done in the past called the point-slope formula, which is y minus y1 equals m times x minus x1. In this formula, you are going to replace y1, m, and x1 with numbers. So, we'll start with y1. You can choose either equation to use. I'm just going to pick, or either point to use, sorry. I'm going to pick the point that's dealing with smaller numbers, but it will work for either point. And in 66, 130, 130 would be the y value. So that's going to replace y1. My slope, I already figured out, was 6.25. And then it's going to be in parentheses x minus the x1 value would be 66. And now I need to simplify until y is alone, so that it's in the equation of the form y equals mx plus b. So the first thing I need to do is I need to distribute the 6.25 to each term in the parentheses. So I will have y minus 130 equals 6.25x minus 412.5. And then the next step to get y alone would be to add the 130 to the other side. And I will finally end up with my equation y equals 6.25x minus 282.5. And this is the equation of the line of best fit that we drew in the beginning. Now, for question 7 and for question 8, we are going to use this formula that we figured out, and we're going to predict the weight of a person given their height. So, for question 7, we have, it says to interpolate to predict the weight of a person that is 64 inches tall. Now, if we go back to our graph, the reason that it's asking us to interpolate is because 64 inches, remember, height in inches, we've got right here, 64, that is inside the range of data. So if I were to guess by looking at my graph, I would go to 64 inches and I would look at the line. Now my line's not perfect because I couldn't really use a straight edge, but I would guess that that person's height would be probably around maybe 116 or so based on my line. So now let's see what we'll get when we actually use the formula. So what we're going to do is we know that height is x, so we are going to replace in the formula with 64 in for x to figure out the y value, which is the weight. So we're going to have y equals 6.25 times 64 minus 282.5. And when I type that into a calculator, I'm going to end up with a y value of 117.5 pounds, which is not too far off from what we guessed by looking at our graph, which means that we are correct. So, question 8 is asking us to extrapolate, which means that this data is outside our typical range of data that we saw on our graph. So if we look, a height of 100 inches is not on our graph. So if we need to predict this by using our equation, remember our equation was y equals 6.25x minus 282.5, we are going to replace the x with 100 inches. So 6.25 times 100 minus 282.5 is going to give us a y value of 342.5 pounds. Now, this might seem like a lot, but if you think about a person that's 100 inches tall and you convert that to something you're more familiar with, like feet, this is actually a person that is 8 feet and 4 inches tall, which is extremely, extremely tall. So that's probably why they weigh so much more than a person who is 64 inches tall, which would be a person that is 5 feet, 4 inches. So definitely a significant height difference and, respectively, weight difference. And that's going to conclude your notes today on constructing and applying scatter plots.